Hey everyone and welcome. Today, we're going to dive into one of the most important programming languages ever created, C. And we're not just going to look at a bunch of code. Nope, we're going to break down the fundamental grammar that computers actually understand, the very language that basically built the digital world as we know it.
Now, that's a pretty bold claim, right? But, it really gets to the heart of what we're doing here. The goal is to strip away the complexity and focus on the core ideas that give C its incredible, lasting power. So, when someone says they're learning to program, what does that actually involve, especially with a language like C? Well, it all boils down to the essentials: how a program stores information, how it makes decisions, and how it keeps itself from becoming a total mess. Let's start with that very first piece of the puzzle: memory.
All right, Section 1, storing information. Before a program can do anything remotely interesting, it has to have a way to remember stuff. We're talking numbers, letters, prices, you name it. Every little piece of data needs a place to live inside the computer's memory. I mean, think about it. If you tell a program your age is, say, 22, how does it hang on to that number? It can't just be floating around in cyberspace. It needs a specific spot with a specific label. And that, my friends, is where variables come into play.
At its heart, a variable is just a named container. It's like you get a little box in the computer's memory, you slap a label on it that says age, and you put the number 22 inside. But here's the cool part: that value isn't set in stone. Next year, you can open that very same box and update the value to 23. That's why it's called a variable.
Now, of course, you can't just name these containers whatever you want. C has some pretty strict rules, which really shows you its philosophy of being precise. For instance, names are case-sensitive, so a lowercase age and an uppercase age are two totally different variables. They have to start with a letter or an underscore, and you can't have any spaces. That's why you see that underscore used all the time for names like final_price.
These containers are also specialized. You have to tell C what kind of data you're going to put inside. The three most basic types are int for whole numbers, float for numbers with decimal points, and char for just a single character. And this isn't just some random rule. By telling it the type, you're helping C reserve the perfect amount of memory, which is a huge part of what makes it so fast and efficient.
Okay, so we can store information. Great. But the real magic of programming happens when you can make decisions and automate tasks that you have to do over and over. This brings us to Section 2, logic and loops.
This is really the million-dollar question, isn't it? We don't want our programs to be dumb and just follow one path. We want them to be smart, to adapt. If a user is old enough, do one thing. If they're not, do something else. And if we need to print a message 500 times, there is no way we're going to type that out by hand.
And this is the fundamental fork in the road for any program, the if-else statement. The code just asks a simple true or false question. In this case, is the value in the age box greater than or equal to 18? If the answer is true, one block of code runs. If it's false, the other else block runs instead. Honestly, almost every complex decision you see in software boils down to this simple choice.
And for doing things over and over again, we've got loops. A for loop is like a little automated machine. First, you set up a counter, usually just called I. Then you give it a condition to stop, like keep going as long as I is less than 5. As long as that's true, it runs the code, adds 1 to the counter, and checks again. And it'll just keep doing that on repeat until the condition is finally false. It's incredibly powerful.
So we have data, we have logic, and we have loops. But as your programs get bigger, things can get messy, really, really fast. So the next step up in programming is all about keeping your code organized and manageable.
Seriously, just imagine a single file with thousands and thousands of lines of code, all jumbled together. It would be an absolute nightmare to read, to find bugs in, or to ever update. Good programming is all about having strategies to keep that chaos under control.
And the number one tool for organization is the function. The best way to think about a function is like a recipe. You write down the steps for one specific task, let's say calculating the area of a circle, and you give that recipe a name. Then, anytime you need to do that calculation, you just call the function by its name instead of rewriting all the steps. It's all about working smart, not hard. But what about keeping our data organized? Think back to our variables. Let's say you want to store information about a student. You'd need a variable for their name, one for their ID, another for their GPA. And yeah, they're all related to the same student, but they're just stored in these separate, disconnected boxes. It's not very clean.
The solution to this is something called a structure, or struct.
It basically lets you invent your own custom data type. It's like creating your own digital file folder. You can design a student folder that has a specific spot for a name, an ID, and a GPA, all bundled together neatly. It's an amazing way to model real-world things right in your code.
All right, we've covered storing data, making decisions, and staying organized. Now we're getting to the concept that gives C its reputation for being both incredibly powerful and, let's be honest, a little bit dangerous: direct control over the computer's memory.
See, most modern languages try to protect you from the messy, low-level details of how memory works. But C, C lets you get your hands dirty. It gives you a tool to work directly with the actual memory addresses where your data is living. This tool is what makes C lightning fast and sometimes a little tricky to handle.
And that tool is called a pointer. This requires a little shift in thinking. A normal variable holds a value, like the number 22. But a pointer doesn't hold the 22. It holds the memory address where that 22 is being stored. Here's the analogy. It's the difference between having $100 in your wallet versus having the GPS coordinates to a vault where that $100 is hidden.
So why on earth does that matter? Well, take a look at this. Normally, when you send a variable to a function, the function just gets a copy of your data. So any changes it makes just vanish when the function is done. But when you send a pointer, you're giving that function the actual address of your original data. This means the function can reach back into your program and change the original value. That is an absolute game changer for performance.
So, we've touched on variables, logic, functions, and pointers. And you might be thinking these concepts sound a little old school. But here's the thing. They are the absolute bedrock of modern computing. Let's wrap up by talking about why C is still so incredibly important today. When you get right down to it, learning C is kind of like learning the Latin of programming languages. Its ideas and its syntax are the foundation that giants like C++, Java, and C# were built on. And its raw speed, which comes from that direct memory control we talked about, is why it's still the king for anything that needs to be super fast, like operating systems, big-time game engines, and all those tiny computer chips in your car or your microwave.
Everything we've covered, variables are like the nouns, functions are the verbs, and all the logic and loops are the rules of sentence structure. It all comes together to form the basic grammar of how computers work. By understanding C, you're not just learning one language. You're really learning how computers fundamentally think.
Grasping these core ideas is the most important step to understanding how software really works. You've now seen the fundamentals of the computer's native tongue. So the real question is, now that you can speak directly to the machine, what will you tell it to do?